Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at the concept non-polar covalent bonding. A non-polar covalent bond is a bond that is formed between two atoms in which they share at least an electron pair equally. The equal sharing of the bonding electrons is as a result of the fact that atoms that participate in this kind of bond either have the same values of electronegativity or they have electronegativity values that are nearly equal. As a result of this, the electron cloud is symmetrically distributed between the two bonding atoms. Now, what this means is that none of the bonding atoms is going to be able to attract the bonding electrons stronger than the other. For atoms that form this kind of bond, their difference in electronegativity usually ranges from 0 to 0.4. Examples of compounds that are formed, compounds or molecules that are formed by non-polar covalent bonding are 1. Hydrogen molecule. In a hydrogen molecule, two hydrogen atoms chemically combine to give you a hydrogen molecule, which is H2. Each of the hydrogen atoms has a covalency of 1. Now, what this means is that each of the hydrogen atoms has only one unpaired electron in its valence electron shell. So, each of the hydrogen atoms donates one electron for sharing, and this electron is shared equally between the two hydrogen atoms. The second example is chlorine molecule. Chlorine molecule is formed when two chlorine atoms chemically combine. Each chlorine atom has 7 valence electrons. However, each chlorine atom has a covalency of 1. So what this means is that each of the chlorine atoms will only donate 1 electron each for sharing. And when that happens, you have this structure of chlorine molecule. The electrons here are the bonding electrons. These are the electrons that are shared between these two chlorine atoms. When you look at the number of electrons in this particular circle, it is 8, which means that in the bonded state, this chlorine atom has an octet configuration. When you also look at the number of electrons in this other circle, it is 8, which tells you that in the bonded state, this chlorine atom also has an octet configuration. The third example is methane. In methane, what happens is that one carbon atom chemically combines with 4 hydrogen atoms. The carbon atom here has a covalency of 4, meaning that it has 4 unpaired electrons in its valence electron shell. Each of the 4 hydrogen atoms here has a covalency of 1. So when this carbon atom combines with these 4 hydrogen atoms, you have this structure here. Now, each of the hydrogen atoms has a duplet configuration, that is 2 electrons. But the carbon atom has an octet configuration. When you look at this circle, this one, this one, this one, discover that each of the hydrogen atoms has a duplet configuration. But the carbon atom, when you look at this larger circle here, the number of electrons in it is 8. The carbon atom in methane has an octet configuration. When you look at the atoms that form this bond, their electronegativity values are not the same. However, because of the symmetrical and tetrahedral shape of methane molecule, Methane is considered overall to be non-polar, despite the fact that carbon atom and hydrogen atom don't have the same values of electronegativity because of its symmetrical nature and because of its tetrahedral shape. The fourth example is oxygen molecule. In oxygen molecule, two oxygen atoms combine to give us O2. And in each oxygen atom, there are 6 valence electrons. But each oxygen atom has a covalency of 2. So it means that each of these oxygen atoms will only donate 2 electrons each for sharing. And when that happens, you have this structure here. When you look at the number of electrons in this circle, it is 8. When you look at the number of electrons in this other circle, it is 8. When you look at the electrons here are the electrons that are shared between these 2 atoms, that is the bonding electrons. There are 4 of them, meaning that there are 2 pairs of electrons. So because of that, there is a double bond formed between oxygen molecule. So it means that oxygen molecule is a molecule that has a double covalent bond. Now we're going to look at the importance of non-polar covalent compounds. Non-polar covalent bonding is found in gases like nitrogen and oxygen. And it is important for us to understand that these gases are the components of air. Nitrogen and oxygen are part of the components or the composition of air. The second one is that non-polar covalent bonding is present in non-polar solvents such as benzene and hexane. And benzene and hexane are very important industrial solvents. 3. Non-polar covalent bonding is important in biological systems for lipid interactions and storage of chemical energy. Lipid molecules have hydrocarbon chains that are made up of non-polar covalent bonds. And lipid molecules are essential for the formation of cell membranes. Also, carbohydrates have CH bonds, and CH bonds are non-polar covalent bonds. Carbohydrates store chemical energy, and during metabolism, especially cellular respiration, these non-polar covalent CH bonds in carbohydrates is broken to release energy in the form of ATP. So I want to believe that the explanation of the concept of non-polar covalent bonding is clear. Thank you for watching and see you in the next video.